Hello everyone, welcome back to another video in our Java series. Today we are going to be discussing something you've probably already run into as you're coding, but we're going to go into it a little bit further. So let's go ahead and investigate how to deal with errors in Java. So as you know, and as you've been creating your programs, you've probably seen some errors pop up. Because when you're writing and you're developing things don't always go as planned. Especially when you start to use data, things can get disorganized and cause problems as you start to forget what goes where, what interacts with what, etc. So you have to think about how your code is going to handle when problems arise. So first, let's consider why our programs might fail in the first place. So far, you might have experienced things like entering the wrong input into the scanner, or even trying to access invalid array indexes or null references while you're working with arrays, now that we've covered that information. There's a lot of problems that you can run into when you're running with your code, but these are some common ones you may see and may have started to see as you've learned more of the later topics in this series. Now, when your program fails, typically it will throw an exception, and when it throws an exception, it will crash unless that exception is handled. So you're pretty much just left with a bunch of text and a bunch of red lines that you don't quite understand. So let's go ahead and learn about exceptions. An exception is when something occurs or an event occurs during the program runtime. Basically, when your program is executing. And it pretty much disrupts how your program is being run or how the outcome comes out to be. Now, considering exceptions, here are the common exception types that you will run into as you are running your code. First, we have your null pointer exception. This is when you are trying to use an item that is established as null, basically meaning that it doesn't exist or it doesn't have a value yet. This typically can happen with strings or arrays, etc., that you may have created but not assigned a value to. Then you have array index out of bounds. So this exception basically is saying that you're trying to access an index that does not exist in the array. Typically, this happens when you use an index value that's greater than the actual length of the array. You also have your input mismatch exception. This typically happens when you're working with the scanner and you input the wrong data value or data type into the scanner, which basically is saying, hey, for example, your scanner is expecting an int, but you type in a string. So that would be an example of input mismatch. And lastly, you have file not found exception. This is when you are working with files in your Java code and pretty much there's an issue with that file, such as it can't be found or it has moved or changed locations other than what you have provided it. But we will get more into the last exception a little later on in the series. So here on the screen is a quick example of an exception. Now, please note that in this screenshot, it is a little bit cut off because exceptions tend to be very long when they come out or they will stretch the length of the IDE that you're using. But we pretty much got the important information we need on this screenshot. Now, if you go ahead and take a look, in the blue at the bottom where it says console, and we see the red text. It tells us exactly what exception we have. In this case, we have a null pointer exception. And it's basically saying that this code we were trying to do is trying to pretty much find the length of a string that does not exist. So what it's telling us in this red text or this error is it's saying it can't invoke string.length because s is null, meaning s is empty. So it cannot return a length, therefore providing a null pointer exception. Here is an example of array index out of bounds exception, as you see in our console output. And in our code, you see that we technically have a integer array, and it pretty much has 3 items in it. Now, when we're doing our print statement on line 7, we're saying we want to access the 5th index of the nums array. And in this case, we do not have that many values in nums. So therefore, it gives us a array index out of bounds exception, basically saying that index 5 is not in bounds of the length of the array. So with that being said, your exceptions are telling you exactly what went wrong, where it went wrong, and they sort of guide you to a solution. So what should you do when you run into an exception? Pretty much what's going on in the background is all of your program will stop immediately once it hits that exception. And basically what happens is Java will create an exception object, and then it would also look for a handler. Once it does those two things, something called a stack trace is printed. Now I know some of these terms are new to you, and we're going to go ahead and look at those now. So first, your exception object. This is going to be an object that's created when the error occurs, and this is going to have the details about that error. So inside of that object, it will say the type of error, it will give you a message describing what happened, and it'll also provide a stack trace, which is going to show where it happened as well. So a stack trace is pretty much just a report about when a execution or exception occurs. So this is going to have pretty much all your exception information, like the type of exception, the message, what type of methods the program was in, or even the line number that the error occurred on. So considering that, this is an example of a stack trace. In this case, it's telling us what type of exception. It's also telling us what we did wrong. In this case, it's saying you tried to divide by 0. It's also telling you where it occurred. So it's telling us here that it occurred in the file demo arithmetic in the main method within line 4. So it's pretty much giving us all the information we need to know, which will help us identify where we need to go fix our problem. Now, exceptions have something called a handler, so exception handler. And basically, this is going to be some code that's going to tell Java what to do when something goes wrong so that your code just doesn't immediately crash and stop running. So this exception handler is going to go in something called a catch block. So getting into catch, try catch is Java's way of handling errors safely. So we are going to take a look at that. So first, let's talk about why we need a try catch before we get into what it is. So basically, if you didn't use a try catch, anytime you have an exception, your program's going to stop and it's pretty much going to print out what went wrong and tell you that you need to fix it. So the try catch is important because it will pretty much let your program recover instead of instantly crashing and or stopping. So a try catch block is pretty much a block of code that lets your program run any code that may be risky and or cause a exception and handle any errors that it occurs. So if you take a look, we have a simple keyword try followed by some curly braces, and inside of the curly braces will be the code that might cause an issue to your program. So we're basically saying we're going to try this code, but it may cause a problem. Now, followed by that try block, we have a catch block. This catch block is where you're going to specify what exception you're hoping to catch if it occurs. So this is just an example exception here, but we basically would say we want to catch this exception, and if we're catching that exception, we're basically saying we acknowledge that this exception happened, but we still want to do something in our code. So that's basically the purpose of a catch. It's very much similar to a if else statement where your try is your if in this case and your else would be the catch in this case. So just think of it similar to that. It's pretty much very much on the lines of if else, where catch is your default if the exception occurs. So try. Again, this is going to be the code that might cause an exception. So if you think it's going to cause a problem, this is where you would put it, inside of the try block. Basically, if no error happens, your program will continue to run. It won't run the catch code. Now, your catch is only going to run if that specified exception occurs in the try block. So it's basically going to receive that exception object and it's going to handle whatever code you stated inside of that catch instead of just crashing and showing you an error. So here we have an example. You see, first we have our try and then we have our catch block. That's exactly how you'd write it. Try always comes first, catch comes second. In this case, we're saying that inside of our try block, we're asking a person to enter an integer. Now, in this case, we don't know if our user is going to enter the correct data value. In this case, we are telling them to enter in a int, but they could enter in something else, such as a string, such as a double, and if that is the case, then our program would crash. So this is why your try catch block is important. Because being that we have set it up this way, if our person were to enter in a double or a string, what will happen is instead of the program crashing, it's going to immediately run our catch block. It's basically going to tell the user what you entered is invalid and we need you to enter this. So it's pretty much just telling the user that they did something wrong, and it's preventing it from pretty much crashing out and you seeing that red error message at the bottom of your screen. Here we have another example. In this case, this is showing you an arithmetic exception, basically saying that you're not doing your math calculations correctly. In this case, you see in our try block, we have two integers, a and b, with b being our value of 0. As you know, you can't divide anything by 0, so that will cause a problem in math, and that will throw the arithmetic exception. So in this case, we're saying that, hey, we're going to try this code. Now, if that code, which in this case we know what type of exception it is most likely going to throw, we're going to say in our catch block exactly what that exception is going to be. In this case, we're saying catch the arithmetic exception, again, because we are going to expect that potentially arithmetic exception can occur with our calculation. That is why we are using catch arithmetic exception E, and we're basically saying print this out if this code causes a arithmetic exception. So that's a good example to see how to change out the exceptions within your catch block. Now, with catch blocks, you can have multiple of them, similar to else if, where you can have pretty much multiple cases of your code. So it's basically saying if this happens or if this exception happens, we'll run this code. Or if this code causes this exception, we'll run this code. Or if it causes this exception, we'll run this code. So basically, it's just giving the user different exceptions in case they run into any of the exceptions during that code run. So basically, how multiple catch blocks works is it's going to go through each catch from top to bottom. And basically, the first one it hits is the one it's going to run. Again, similar to your if, else, if statements. The first one it sees is the one it's going to run. So, if there's a case where you want a specific exception to happen or you're expecting that one to occur more commonly, then you should place that one at the top rather than the bottom. So, think of the bottom as more so your defaults, rare cases. So, just put anything you're just putting just for safety precautions at the bottom, but anything that you're expecting that will most likely occur out of the exceptions, always put those at the top. So here's an example of multiple catch blocks. In this case, we have two catch blocks, one for a number format exception, the other for the arithmetic exception. Now, in this case, you see we are working with some numbers in our try block. Now, being that we're working with numbers, we know that these are some exceptions that are basically linked to any numbers you're working with in your code. So, being that you're working with numbers and these exceptions are possible, you may want to just put in a catch block for both exceptions because you don't necessarily know which one you're going to run into. Either a user could enter in the wrong number value, or they could even enter in the wrong math input. So, either way, in this case, if you put two exceptions, then you know at least one will run in this case. So, either your try will work perfectly, or if that doesn't work, then one of your catches will work in this case. So now that we've pretty much gotten into what a try catch is, we're going to discuss something called a finally block. Now, a finally block has code that will always run, whether an exception happens or not. So it will always run. And basically, it's going to be used for tasks that you have to do no matter what, such as closing a file or closing scanners or saving data, which again, some of these topics are going to make sense in our next lecture. But basically, a finally block can be useful in certain cases. So, what that would look like is you would first have a try, then you would have a catch block, and then you would have a finally block. So, again, what will happen in this case is it's going to try that code. If the code works, fine. If it doesn't, it'll hit that exception, depending on if you put the correct exception in that catch block. And regardless of that, it will do a finally, which is going to pretty much run after all of that is done. So here we have an example of your try, catch, finally. So in this case, we have a scanner and we're having a file in there called data.txt. Now, in this case, what this code is doing is it's saying it wants to print out what's in the scanner or the file. Now, in this case, we have an exception, and it's basically just going to give us a generic exception if something goes wrong, and it would basically say to the user something went wrong. Now, if that exception never occurs, that's fine, or even if it does, basically what's going to happen is that next step would be the finally, where it's going to pretty much print to the user that it's going to close the scanner out, so followed by closing that scanner. Now, again, this kind of deals more so with dealing with files, which we haven't gotten to, but this is just a good example of how you can create and use a try, catch, finally block of code. So the key takeaways here for today's lecture: you're going to run into errors. It happens all the time in development, especially when you're first getting started. So when these errors occur, your exceptions happen and they pretty much stop or crash your program. So it's important for you to know how to use a try catch block to pretty much solve these problems or at least get over them. So error handling is going to be very important to ensure that your user experience runs smoothly and your user does not experience unexpected program crashes due to issues that they were having with the problem. So basically what we covered today is dealing with exceptions. And with exceptions, you have exception objects and handlers that work with it. Now, using all of that information, we would implement a try, catch, or finally block, or all three, or two of each, try and catch, to pretty much help us resolve those issues. So you can do a try catch block, or a try catch finally block, or a try catch 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 finally block, etc. to help you get over these exceptions. So overall, you can avoid those program crashes and allow your code to keep running no matter what. So that's everything we're going to cover today for error handling. Coming up next, we're going to have our coding tutorial on dealing with some of these errors just to show you what it looks like in real time. And after that, we'll pretty much get to wrapping up our series and we'll end it off with using files in Java. So stick around because you've almost made it completely through this Java series, and then you should be on your way to being a great Java programmer. So I'll see you in our coding tutorial coming up next.